Professor Eric Atefa, and we will be continuing with our programming with C++ last week. Then this is our last section for this tutorials. So to commence, let's start with the objectives. Thus, we'll be learning the concept of operator overloading, learn about derived classes, learn how to implement inheritance and polymorphism. So let's start with operators. So let's start with operator overloading. This is really cool features that allows you to define how operators work with our custom classes. Think about it this way. When you write 5 plus 3, the computer knows exactly what to do. It adds 2 numbers and gives you 8. But what if you have 2 objects of class you created? What should be the plus operator to do there? Operator overloading lets you define exactly what happens when you use the operator like your plus, your minus, your asterisk, and your equal to sign, and many others with your custom objects. For example, if you have a point class representing coordinate, you might want point 1 plus point 2 to add their x and y coordinates together. Or if you have a string class, you might want to concatenate 2 strings. So let me show you. So let's move on to a quick review here. Before we dive deeper, let's quickly review operator with commonly used. So we have the arithmetic options, operations. We have the logical operations. We have the relational operations, the pointer operators, and memory management operator. So this is the operator overloading types we have. We have types of operator overloading. We have the function overloading and we have the operator overloading. So with the operator overloading syntax, we have the return type, the operator, and your symbol, bracket your parameters. So let's move on to operator overloading breakdown. So the return type, when we talk about the return type is a type of value the operator returns. The operator, this is a special key that tells C++ we are overloading an operator. The same way, the actual operator we want to overload, like the plus, minus, the increment sign, and so on. Have the parameters. The parameters is defined in the function. So and have a sample example here. That's the int operator, the increment int age, return 0. So let's move on to the forbidden overloading rules, the rules that you have to follow. Now there are some important rules you need to know about operator overloading. So operators you cannot overload: the conditional operator, the scope resolution operator, the dot operator, the pointer for members, you have the typed operator, the size of operator, the line of operator, and other rules are other important rules are you can only overload existing operators. You can't change what the operator does with the built-in types. At least one operand must be a user-defined type. You can't change the number of operands an operator takes. The precedence and the associative of the operators remain the same. So let's move on to advantages. So some advantages of operator overloading. We see simplified syntax allows the user of notations closer to the target domain. Consistency. simply support to built-in types or for user-defined types. And we have easy understanding, use of familiar operator with user-defined types. And we talk about disadvantages. So we have the potential misuse. The abuse or misuse can lead to unexpected behavior, complicity, overuse or misuse introduce complicity. We have limited overloading. Not all operators are overloaded. So let's move on to derived classes. We'll talk about now. Let's move on to derived classes. This is where the thing gets really interesting. A derived class is a class that's created from an existing class. Think of it like this: if you have a general vehicle class, you might create more specific class like car, motorcycle, or truck from it. The original class is called the base class or the parent class. The new class created from it is called the derived class or the child class. The derived class inherits all the members and functions from the base class, but it can also add its own unique features. That's the derived class. And let's move on to the derived class definition. So it begins, let me talk about this here. So begins with the keyword class followed by the derived class name, then colon, followed by access specifier and base class name. The structure for writing a derived class definition is as shown on my screen. And let's move on to derived class revisited. So begins with the keywords class followed by class name. So these are also the structure of it. Now let's move on to derived class code, derived definition codes. Here are some codes you have to get aware of. Child get grade, get blah blah blah. This is it. So now let's move on to derived class using a modifier. Derived class using a modifier. When creating a derived class, you can control how the base class members are inherited using access modifiers. So here are some syntax you have to be aware of. That's class group record, public my record. So now let's move on to derived class using access modifiers. Now let's talk about the public. So with the public, if a derived class is declared in public access, then the members of the base class are inherited by the derived class, just as they are. So let's commence with the private. If a derived class is declared in private access, then all the members of the base class becomes private members in the derived class. Private members in the derived class, sorry. Let's move on to derived class using access modifiers. So protected. The public members of the base class become protected members in the derived class. The private members of the base class are always private in the derived class. So derived class using access modifiers. These are syntax. Class group D records. That's my public my record. Class group I record. Private my record. That's class group G record. Protected by record. So let's move to inheritance. So inheritance is one of the core principles of object-oriented programming. It allows us to create new class based on existing ones, promoting code residue and creating logical relationship between classes. Think of inheritance like a family tree. A child inherits traits from their parents, but they can also have their own unique characters. So here are some comprehensive examples that you can know. You have the derived class. That's so. So inheritance flow process. That's the animal you can see here. This is the base class. That's a dog. It's a derived class. So now let's get some codes. These are simple codes you have to know. If you take your time to run it, I think you'll be cool with it. Let's move on to inheritance type. There are 5 types of inheritance. You have the single inheritance. This is the simplest form. One derived class inherits from one base class. That's the single inheritance. And you have the multiple inheritance. A derived class inherits from multiple classes. And you have the multi-level inheritance. This creates a chain inheritance like family tree going down multiple generations. You have the hierarchical inheritance. Sorry if I didn't pronounce it well. Hierarchical inheritance. This is multiple derived classes inherit from the same base class. You have hybrid inheritance. This combines multiple types of inheritance. So let's move on to important rules for inheritance. So as you can see, this is a clear flow chart of single inheritance. This is the multiple inheritance. This is the inheritance, that's the multi-level. This is the inheritance, that's the hierarchical inheritance. So this is the hybrid combination of two or more inheritance. You have the inheritance rule. So now let's dive deeper into that. So we said static members are called dependent and are not inheritable. Friend classes are not inheritable. Constructors and destructors are not inheritable. And let's move on to polymorphism. So polymorphism, now let's talk about polymorphism. This is where things get really exciting. Polymorphism means many forms. It's the ability of different classes to be treated as an instance of the same base class, whilst each class can have its own specific implementation of the same method. Think of it like this. If you have different type of animals, yeah, they all can make a sound, but each animal makes a different sound. A dog barks, a cat meows, and a cow moves. The action is the same. That's making a sound, but the implementation is different from each animal. That's the polymorphism. Now let's get some code. These are codes in inbuilt codes for writing polymorphism. So this is the end of our lesson with programming with C++ for with 10 section, and this is our last tutorial for the C++ programming for this tutorial. Thank you one more again for joining the class from week 1 to week 10. I hope you people will practice well to have a clear thought and to have a clear understanding about what you've learned from week 1 to week 10.